friends, welcome all of you in Shrived Education. So today we will have the look on the Bernoulis principle. So what Bernoulis principle consists of? Bernoulis principle consists of one pipe which has two opening. You can see a opening B and opening D. Now through this pipe one incompressible and non-viscous fluid is flowing. What is meant by incompressible? That means if we are putting pressure on that fluid, still the density remains the same. And what is mean by non-viscous? That means the frictional force between the layers of the fluid, that is absent, or that is negligible in the nature, right? So now we are considering the two regions. From first opening, the region BC, which is at the height h1, the liquid which is entering in the BC is BC with velocity v1, the pressure of that liquid is p1, and area of this cross section is a1. Similarly, the terms related with the opening E, where we are considering the cross section DE, right? This DE cross section is at the height h2. The pressure of a liquid which is coming out of the DE is P2. The area occupied by DE is A2. And what is the velocity? Velocity is V2. Velocity is V2. Now what we are considering as liquid which is entering through this pipe is equal to the liquid which is coming out through this pipe. That means we are considering the speed of that liquid or speed of that fluid. So what is speed? Speed is equal to distance upon time. So we can write distance is equal to speed into time, right? So now we are writing some terms for two cross section, that is BC and DE. So here we have written for BC and for DE. Now we are writing the distance. That means the liquid which is the fluid which is entering through BC. What is the distance traveled by that fluid? D1 is equal to velocity into time. That is D1 is equal to V1 del T. Similarly, the liquid which is coming out through the DE, that is D2 is equal to V2 del T. Right? Now, as liquid is entering, that means that is displacing, and we know that displacement of anything is nothing but the equivalent to work done. So what is work done? Work done is equal to force into displacement. So again we are writing the work done for two regions, BC and DE. Work done is equal to force into displacement. So what is force? Force is nothing but the pressure into area. So pressure into area for first cross section into D, right? And similarly the pressure into area for the second cross section D into D. But what is this D is? D is nothing but the displacement, and we already have the value of displacement V1 into del T, and that we have kept here, that is P1 A1 V1 del T. Similarly we are putting the value of D over here, V2 del T, right? Now what is area into velocity into time is length, and length into area is nothing but the volume. So we got work done is equal to work done of cross section BC, which we have considered 1, equivalent to P1 del V. And what is the work done of 2? That is the second cross section W2, which is again P2 del V. Again V2 into del T is the length, length into area is the volume, right? So we got the two work done, first and second. And this work done, that is liquid entering in the pipe, is equal to liquid leaving through the pipe, right? And whatever the work done liquid or fluid is doing during this time, that work done is utilized for increase in the kinetic energy and potential energy. So how we can write the kinetic energy? Kinetic energy is 1/2 mv square. But what is, how we can write the M? Density of the fluid which is passing through the pipe is rho is equal to mass upon volume. So what is mass? Mass is equal to rho into volume. So we are putting the value of mass as rho into volume. That is kinetic energy is equal to 1/2 rho del V, that is volume, right? That is volume into V2 minus V1 bracket square. That is the change in the velocity. V2 is the velocity of the liquid which is coming out through D, and V1 is the velocity of the liquid which is passing into BC region, right? So this is the value of kinetic energy. Now what is the value of potential energy? We know that potential energy is mgh, but again m is nothing but density into volume. So rho into del V is m, g as it is. Now what is h? As we know that this pipe is situated in this pipe, the D region is situated at height h2, BC region is situated at height h1. So what is the difference in the height? h2 minus h1, right? So as we have the value of kinetic energy and potential energy. So again, what is the Bernoulli's principle? Whatever the work done is there from displacing the pipe, displacing the fluid from BC to DE, that work done is utilized to increase the kinetic energy, potential energy, and do the variation in the pressure, right? And that is constant for all the region. Now we have considered the two region. We can consider the more region in this pipe, but everywhere you will get these three terms constant. So what is the Bernoulli's principle? Kinetic energy plus potential energy plus pressure of the incompressible and non-viscous fluid entering through the pipe is constant. And similarly, we can put up the value of kinetic and potential energy from upside over here. 1/2 rho v square plus rho gh plus p is equal to constant. So this is all about the Bernoulli's principle. So friends, if you like my video, please like, share and subscribe. Thank you.